Hello there guys, and welcome back to another epic Inexorable video. In this video we're taking a look at solving simultaneous equations by substitution. What's substitution, guys? Let's find out. Okay guys, so substitution. Okay, what's that? Substitution, what does the word substitution mean? It means put something where something was and substitute it, right? Like it's like that scene from Indiana Jones, yeah, with the sandbag, you understand? So it's putting something there instead, okay? Now, why would we do that? Again, just like in the previous video when we're talking about elimination, the whole point of a simultaneous equation, in fact, the only way that you can really do it is by essentially rewriting one of the equations in terms of only one variable, either the x or the y. Or hypothetically, if you had like a triple simultaneous equation, maybe it has a z in it, again, it's the same principle. You need to rewrite one of the equations in terms of just one variable and then solve it that way, okay? Unless you use a matrix, which you're not going to because you're not doing further maths. Okay, well maybe you are, but you just want to watch this video. So, okay guys, now, when do you use elimination? When do you use substitution? Preferably, use whichever one you're most comfortable with. But if you're happy with both, use elimination when you just have lots of different things and you can easily see, oh, I have one of the equations is sort of like it has something in it that's a multiple of the other one, and I can multiply by it and I can take them away or add them together. That's nice. Use substitution if you have a variable on its own, like a 1x, right? Or like a 1y or something like that, okay? That's just better because I'll show you how to do it, and to me it's just better. So how do we do it? Right, this is how you do substitution. Again, I am going to label that equation 1 and that equation 2, okay? So the top one is called equation 1, the bottom one is called equation 2. These are not part of the equation, they're just labels. They've got nothing to do with the question. I just called them 1 and 2. Please do not think this is part of the problem, okay? These are just labels, right? We could have called them thing 1 and thing 2, right? Cat in the hat. We could have called them anything we want, not part of it, right? We could have called them red and blue, or literally anything. They're just random labels, okay? So equation 1, I'm going to rewrite equation 1. I'm going to rewrite equation 1 in a different way, okay? Instead of multiplying it out, I'm going to solve for x. I could solve for y, but it's easier to solve for x because x is on its own and we have a 3y there. I don't really want to deal with a 3y trying to, okay, now I've got to divide it by 3 and oh no, that's going to be an awful fraction because there's an 11 there. 11 divided by 3 isn't nice. 1 divided by 3 isn't even nice, guys, because that's a third. We don't want to deal with fractions like that. So I'm not going to divide by anything. I'm going to try and get the x on its own, okay? So I'm going to write x equals, and now I'm going to take 3y away from both sides, okay? So x is equal to 11 minus 3y. Boom. So I actually know what x is in terms of y. I just know what it is. Every time I see an x, I know that's actually equal to 11 minus 3y, okay? That's a y, okay? All right, now guys, I'm going to substitute, that's why it's called substitution, x as 11 minus 3y. So in equation 2, I'm going to write equation 2 as 4 times 11 minus 3y minus 7y equals 5, okay? Why have I done that? You see there was an x here originally? Where the x was, I put this new definition of x. So this is what x is. We figured out this is what x is from the first equation, and I have put it into the second equation, okay? And now you'll notice, if we expand those brackets out, again, we can just solve it for y. So let's do it, guys. Let's expand this out. So 4 times 11 is 44, minus 4 times 3y is 12y, so it's going to be 4 times minus 3y is minus 12y. And we're still going to take away, I need to make sure my y's definitely look like y's. That's a bad character flaw of mine. My y's sometimes look like x's. So, okay. So we've expanded this out. We've got 4 lots of 11, 4 lots of minus 3y. That's 44 minus 12y. Minus 7y, still there, equals 5, still there. Now guys, let's group up these like terms, all right? I'm going to take 5 away from both sides. That's going to give me 39 minus 12y minus 7y equals 0, okay? And now I'm going to group the y's together. So I'm going to say 39, now minus 12y, take away another 7y, is going to be minus 19y, okay? That's equal to 0. And I'm going to add 19y to both sides because I don't want negative 19y. So I'm going to have 39 is equal to 19y. Okay, I've added 19y to both sides. Now I don't want 19y, I want y. So I'm going to divide both sides by 19. I'm going to get y equals 39 over 19, okay? Now just looking at it, I'm trying to figure out whether that divides, and it doesn't look like it does. So it doesn't appear to be actually divisible, so that would be our answer for y. I would just leave it like that, okay? I'd leave it as a top-heavy fraction. That's totally fine to do in A-level maths. You can have top-heavy fractions, not a problem, okay? So now, whenever we see a y, we're going to choose either equation. Again, I'm going to go with the top equation because we want x now. We want to find out what x is. We know what y is. And I've got a 1 lot of x there. It's just easier because otherwise we'll have to times this out by minus 7, which is just a pain. And then we'll have to divide it all by 4 and deal with the 5. Let's just use this. Let's just use this, okay? And let's substitute, because this is equation 1 in a different way. So let's actually just substitute y, where we see the y there, and we'll be fine and dandy, and then we'll get what x is. So guys, I'm going to say that x is equal to 11 minus 3, and what was y again? Y is that, we just figured it out, 39 over 19, like so. And then guys, we just need to expand that out, okay? So we're going to have x equals 11 minus 3 times 39 over 19. And because, guys, you're allowed a calculator, and my mental arithmetic is not that good, I'm just going to use a calculator. Because you're allowed a calculator in an exam, and you're going to get x is equal to 92 over 19, okay? Doesn't actually look like a 19. That is a 19. My 9s are a bit weird. There you go, 92 over 19, okay. So guys, again, the answer, ANS answer, x equals 92 over 19, y equals 39 over 19. So again, if the question asked you, hey, where do these lines intersect? What would you say? You would write intersection of lines at 92 over 19, 39 over 19. Why? Because that is the x coordinate, that is the y coordinate. We just did it. And again, just to be very clear, that means these numbers represent the numbers that you can substitute into whenever you see an x and a y respectively. You can substitute those numbers in, 92 over 19 and 39 over 19, to make both equations true simultaneously. Because again, there are plenty of numbers that will satisfy one equation individually. So you could choose a value for x and a value for y, be totally fine. You could make the top one true, you could make the bottom one true, but there's only one value for x and one value for y that makes both of these true at the same time, and that's what we're doing, okay? So that is substitution. So what you're doing, you're going to solve for one of the variables from an equation of your choosing, whichever's easier, and you're going to literally just substitute it into the other one. Whenever you see an x, whenever you see a y, just put it in, and then you will have an equation that is only in terms of either x or y. Easily rearrange it. If you need more time to rearrange, if you need to practice it, it's fine. But this should be a skill we already know how to do. So we're going to solve for x or y. We're going to then find out what that number is, and we're going to put it back into, again, either equation, whichever one's easier. If you're thinking, oh no, which one is it? just remember, it doesn't matter. If you really have no idea, just do either of them, okay? But just look at the one that's easier. Like, substitution is good because normally you will actually have to work out something like this, and then you can easily just go, yoink, 39 over 19, put it there, 3 times 39 over 19, 11 minus that, that's x. Easy. Okay? So that's the concept behind substitution, okay? We're going to continue simultaneous equations, but they're going to get a little bit more difficult because we're going to start looking at things being squared and stuff like that, okay? And that's going to come into our quadratics skills. Anyway, guys, thank you so much for watching, and I'll see you in the next one.